Hey guys, this is Mrs. Harbin, and we are starting our next unit in advanced math all about geometry. Hopefully you'll find this easy to begin with and maybe refresh some things that you've forgotten over the years. So let's go ahead and get started with some definitions. Right? Our objective, though, before we dive into our definitions for our unit, but specifically for today, is that you will define and use the geometric terms line, line segment, ray, plane, and point correctly, and that you will find the missing angle in polygons. And primarily, we're going to be focusing on that second objective, finding the missing angle in polygons. So here we go. Let's talk about some definitions here. Plane geometry. You guys should know that geometry has to do with shapes. You've taken geometry already. And when we talk about plane, P-L-A-N-E, we're not talking about an airplane or something that's not decorated, but in fact, we mean flat, right? So plane geometry is all about shapes like lines or circles and triangles and shapes that can be drawn on a flat surface or a plane, a two-dimensional plane. Now, one of our objectives was to define point and line segment and line. So let's take a quick review here. And remember that this is just a point. There it is. And if we put a bunch of points together, side by side by side, eventually what you will have, now my points are not very small, is the beginning of a line segment or a line. And so when we talk about shapes like lines, circles, and triangles, we're really just looking at line segments that are made of a bunch of points. And all of these line segments and points are on this flat surface called a plane. In our study of shapes, we have a specific kind of shape, lots of subcategories here, but a specific kind of shape called a polygon. And a polygon is a shape with straight sides. To be classified as a regular polygon, all the sides and angles must be the same. So some examples of polygons, see if you can think of some on your own. Hopefully you thought of things like triangle, square, rectangle, parallelogram. All of those are closed shapes that have straight sides. And some non-polygon shapes, hopefully you thought of circle or oval. Those are some shapes that are not polygons because they do not have the same sides. Within the category of polygons, we then have regular polygons, where the sides and angles must be the same. If you look at this triangle, all three sides are exactly the same measure, and all three angles are exactly the same measure. This is an equilateral triangle, or a regular triangle. We also have a regular pentagon. All of the sides and angles inside are the same. So this angle is the same as this angle, is the same as this angle. These interior angles are all the same. Over here we have a six-sided hexagon, and it is a polygon. The sides are straight, but it's not regular because the sides and angles are not all the same. So let's take a quick review. Hopefully you know these shapes. So let's take a look. We've got a three-sided polygon, also called a triangle. If you're looking for a definition, that was a three-sided polygon. And we have a four-sided polygon, also called a rectangle. And another four-sided polygon is actually a specific type of rectangle. A rectangle has four sides with four 90-degree angles. This also has four sides with four 90-degree angles, but all the sides are the same. So we could even call this a regular rectangle if we wanted to, but instead we have another name for it and we call it a square. Now what about a five-sided polygon? Hopefully you knew that was the pentagon. A six-sided polygon is a hexagon. Seven-sided polygon is a heptagon. An eight-sided polygon is an octagon. And if you've never paid attention to our roots beforehand, you should know that octa means eight. I'm having a hard time underlining here, like octopus or octogenarian. Those are words that have a root or have something to do with the number 8. A 10-sided polygon is a decagon. Hopefully this looks familiar to you because this is the root of the word decade, which is a period of 10 years, or a decathlon, which has 10 events. Deca means 10. All right, what about 12 sides? I'd be impressed if you knew this one. 12 sides is dodecagon. Dodecagon. Some other special names for shapes. Again, we have kind of lots of subgroups within this polygon family. For any four-sided shape, we have the same quadrilateral. And again, looking at roots here, quad is our root. It's also the root for quarter. It's also the root for your quadricep, which is a muscle, actually, muscle group made of four muscles. So a quadrilateral is any four-sided shape. So not a triangle, not a circle, but lots of other four-sided shapes. We've already talked about the fact that a rectangle has four sides with all right angles, and a square is just a special type of rectangle. It has four sides, all right angles, and all the sides are the same. As mentioned earlier, a polygon does have to have straight sides, so some shapes that are not considered polygons would be our circle and ellipses, or circle and oval. This is our ellipses, the mathematical name there, another name for oval. All right, let's turn our attention to the second objective, which is the sum of the interior angles. And sum, you know, means we're going to add. So we want to know what all of the interior angles add up to. In case you've forgotten what an interior angle is, in an enclosed shape, the interior angles are the angles formed by all the line segments inside the shape. So I just drew some interior angles there. Exterior angles, which we're not worried about today, are the angles that are formed between, like if we drew this green line here, like the ground underneath that triangle, between the outside edge of the shape and the ground, for lack of a better way to describe it right now. All right, we extended that line here. There we go. So those are our exterior angles, but we're not worried about those today. We're only worried about the red ones, the interior angles. Right? And to find the sum of the interior angles of any polygon, which is what we're working on, we take the number of sides minus 2, and we multiply that by 180. If we had a triangle, for example, we would take the number of sides, 3, minus 2, and we would multiply that by 180. And 3 minus 2 is 1. 1 times 180 is 180. And we do know that the interior angles of a triangle add up to 180. If we wanted to find the sum of a different shape, like a pentagon, we would take the number of sides, in this case 5, subtract 2, and multiply all that by 180. And 3 times 180 is 540. Right, let's do a couple of problems together, finding the sum of the interior angle here. We're also going to practice our vocabulary. So first of all, how many sides does this shape have? If you have trouble mentally marking things, it can be helpful to you to make these little hash marks while you're counting, especially with larger shapes. But if you count the sides, you see that it does have, in fact, 8 sides. So its proper name is an octagon. It's not a regular octagon. You can tell that this bottom and this top side are a little bit longer, and the angles are not the same here. So it's not a regular octagon, but it is an octagon. The sum of the interior angles, again, we would take the number of sides, which is 8, subtract 2, and multiply all of that by 180. So the sum of the interior angles is 8 minus 2, which is 6, times 180. And then when we do that, we get 1080 degrees. So to find the measure of the missing angle, we're going to take 1080 and subtract all of these known angles that I have here. So I notice that I have 4 of the 140 degrees and 3 of the 135 degrees. So I'm going to take 1080 and subtract 4 140s and 3 135s, and I find that my missing angle is 135 degrees. Do make sure that you include that degree symbol there. All right, let's try another one. First, let's identify the number of sides. Number of line segments forming this side is equal to 5. It is not a regular pentagon. We can see that the sides are not all the same length, nor are the angles the same measure, so it's definitely not a regular pentagon. But That doesn't matter if it's regular or not when we're finding the sum of the interior angles. We're going to take the number of sides, in this case 5, minus 2, and multiply that by 180. And when we do that, 5 minus 2 is 3, times 180, we get 540 degrees. To find the measure of the missing angle, we then take our 540 and we subtract the known angles. So 540 minus the 65, 135, 95, and the 165. And when we do all of that, we find that our missing angle right up here in the corner is 80 degrees. All right, guys, short and sweet. Today we defined and used geometric terms: line, line segment, ray, plane, and point. We did not, let me go back and rephrase that. We use the geometric terms line, line segment, plane, and point. We didn't talk about ray today, but we'll talk about that in class. We did find the missing angles in polygons using our formula for the sum of interior angles, which is the number of sides minus 2 times 180. We'll be sure to define these geometric terms, line, line segment, ray, plane, and point, in greater detail when I see you guys in class. Be sure to write down any questions you have, and I'll see you soon.